In the previous section, we've introduced some HTML5 and CSS3 features, which are mainly used for UI construction. In this section, we'll gradually go through how to build an app with the help of frameworks, how to optimize JavaScript code, and how to increase the quality of JavaScript code using unit tests. In this video, we will mainly focus on a framework called Sencha Touch and demonstrate how fast an app can be built with Sencha Touch and deployed to mobile devices with PhoneGap. JavaScript has a very long history. We use the JavaScript 1.5 standard for the whole course, which is currently the most popular and widely supported version. There are major differences between PhoneGap mobile application development and web page development. All those differences indicate that PhoneGap mobile applications are more like a rich internet application with the accessibility of device functionality. The client of the PhoneGap app is relatively more complex. We need to be more careful when designing the JavaScript code structure. To simplify mobile app development, we usually use a framework. Frameworks help a lot with regard to cross-platform functionality, code quality, and development cost. We can use frameworks to develop feature-rich and high-quality apps with little effort. We will introduce two frameworks in this course, Sencha Touch and jQuery Mobile, both of which have very good features. Sencha Touch is a high-performance HTML5 mobile application framework. You can use Sencha Touch to produce a native app-like experience inside a browser or in a hybrid shell. Sencha Touch supports Android, iOS, Windows Phone, Microsoft Surface Pro and RT, and BlackBerry devices. Sencha Touch allows developers to build UIs quickly without worrying about the difference between mobile browsers. The detailed Sencha Touch documentation helps a lot if you want more details, and it's not difficult to master. It contains development tools that help manage Sencha app development. Besides, Sencha Touch is based on the model view controller pattern, which is also applied to Sencha Touch apps. It dramatically increases the readability of applications. Sencha Touch is now at version 2x. Before using it, we need to check if our system meets the basic requirements. First, download the Sencha Touch SDK from the Sencha website. Keep in mind that the versions will differ according to whether your project is commercial or open source. You can skip this step if you've downloaded the SDK before. Then, check if your Java and Ruby versions meet the requirements. Open a terminal, type in java-version and ruby-v to see if the version meets the basic requirements. Once Java and Ruby are in place, we need to install the Sencha command line tool, which manages the Sencha Touch project lifecycle. Download the Sencha CMD package from the Sencha website. Run it and follow the steps to set up the Sencha CMD tool. After installation, run Sencha in the terminal and you should see some output. If you got any errors, check the requirements and reinstall. In this video, we simply introduced some reasons why we should use a framework for app development and how to install the Sencha Touch framework. You should be able to install the Sencha Touch framework, which will be used in the next video. In the next video, we will demonstrate how to initialize, develop, and deploy a Sencha Touch-based mobile application. In the previous video, we learned some of the basic concepts of app frameworks and installed the Sencha Touch framework. In this video, we will demonstrate how to develop a mobile application using Sencha Touch and deploy it to mobile devices using PhoneGap. In this video, we will also introduce a model view controller pattern, which is the recommended structure of a Sencha Touch app. Meanwhile, we will also learn how a Sencha Touch app can be organized. We installed Sencha Touch in our last video. Here, we will create a Sencha Touch app and deploy it to a mobile device within minutes. You will also find how powerful and convenient it is to write a mobile app with the Sencha Touch framework. First, open a terminal, create a folder for your project, and change directory into that folder. Then, extract the Sencha Touch SDK zip file downloaded in the last video and copy the contents to the project folder. You should see the content in your project folder as shown. Run the command sencha generate app sencha demo in our project folder. This will generate the basic structure for the Sencha Touch app. If you fail here, you need to take a look at the requirements again. Once the generation is complete, we will have created our Sencha mobile application. We can now view it in the browser. In the project folder, run the command sencha fs web start. Sencha will create a simple web server. Open the web server URL in the browser, and you'll see how your application currently looks. Now we will make some changes to the app. The Sencha Touch projects follow the model view controller pattern, which is being used in all of your PhoneGap mobile applications. Basically, the controller controls the view and model to perform methods based on user action. The controller subscribes the user action events from the view. The view subscribes data changing events from models and renders the UI based on data returned from the models. Models define business logic, which contain data processing and data exchange. Now, in our project, open the app.js file. The Sencha command line tool generates the code here automatically, and we generally don't need to change it. We will introduce our application and Sencha Touch from here. Sencha Touch has very detailed documentation. Open a browser, go to docs.sencha.com/touch. The first line of the code is ext.loader.setPath. In the documentation, we find that this line sets the source path for the ext namespace. We can ignore it for now as it has little value. The next statement is ext.application with a JSON object as the parameter. In the documentation, we find the explanation of these parameters. The most important one is the defined launch function, which will be called to render the initial UI when the app is ready. We can find that the generated code added the main view to the viewport. To change the application, we need to change the main view. If you want to change some other functions, such as a user event handler or data processing, you will need to change the controllers or models. We can see a view folder which contains all views, in which there is a main.js file which has our code for the main view. It's possible to find the explanation for the parameters in the Sencha Touch documentation. I will simply introduce them to you here. ext.define on the first line will define a namespace for a Sencha view object. It extends from the ext.tab.panel, which means that the view has all features of a tab panel. Then, it gives its unique X type and declares that the view requires a Sencha Touch title bar and video components. After that, its config defines the position of the tab bar. The items parameter declares the children items inside the components. Now, the component has two items. Each item is a standalone Sencha view object. The first item is the welcome page with a title bar docked on the top. The second item is the Get Started page with a video content inside. This is how a nested Sencha Touch view works. You can either define a view in a single file and refer to it in another view, or embed the view definition in the view directly. As we understand the view structure, we will also go about changing the items in the main view. We first remove all the existing items and add one item with the title About, which will be displayed in the tab bar and a star class as the tab title icon. In the HTML code, we simply say Hello World. After refreshing the browser, we can see that the change is applied immediately. Now we can add the title bar, which is regarded as an embedded item in the About page. Let's dock the title bar on the top with the title Sencha and PhoneGap, and refresh the browser. We will see that the title bar has now been generated. Now we have a basic mobile app with both the tab bar and the title bar structured in minutes with no more than 20 lines of code. Once the Sencha Touch app is developed, we will be able to use the PhoneGap commands introduced to deploy an app to mobile devices. The steps are as follows. First, we need to add the Cordova script file to index.html. This will enable our Sencha Touch app using PhoneGap APIs. Then run the Sencha app build command, which builds a production version of your Sencha Touch app. Remember the location as we'll be using it later. Use the Cordova create command to create a new PhoneGap app. Copy and paste the production files from the earlier location to the Cordova project's www folder. Remove the Hello World project first. Finally, use the Cordova command line tool, add supporting platforms, and run the Cordova prepare commands. This is how we deploy it to an iOS emulator. Now run the application directly without any changes. In this video, we used the Sencha Touch framework to build an app and deploy it to a mobile platform using PhoneGap. Sencha Touch is a comprehensive mobile application framework. For more information, please check out the Sencha Touch documentation. In the next video, we will introduce another app framework, jQuery Mobile. In the previous video, we introduced the framework and discussed how to use Sencha Touch to develop a PhoneGap mobile application. In this video, we will introduce another framework called jQuery Mobile and discuss how to deploy jQuery mobile applications to mobile devices using PhoneGap. jQuery Mobile is based on the jQuery framework, which is a cross-browser JavaScript library designed to simplify the client-side scripting of HTML. jQuery contains a series of features like DOM and CSS manipulation, HTML event methods, AJAX, animations, and utilities. The jQuery mobile application is HTML5 based. jQuery Mobile supports more mobile device platforms compared to the Sencha Touch framework. I will demonstrate how to write a jQuery mobile application with a simple page and business logic. First, download the latest version of jQuery and jQuery Mobile. Here, we need to download jQuery 1x rather than jQuery 2. Create a folder for our project. Inside it, create the CSS and JavaScript files. Then, copy the jQuery Mobile CSS file and images folder to the project's CSS folder. Also, copy the jQuery Mobile JavaScript file to the project's JS file. Finally, copy the downloaded jQuery JavaScript file to the JS folder. Now we have imported the jQuery mobile libraries into our project. The next step is to create an index.html file to link those libraries. Now we add our first jQuery mobile page. jQuery Mobile uses HTML5 data attributes to identify the functionality of a HTML element. For example, a div with data role as page is defined as a full-screen page in jQuery Mobile, and a div with data role header, in the example, will be rendered as a fixed page header at the top. Let's take a look at the browser. Unlike Sencha Touch, which creates a web server for the preview, you can either open the file directly in the browser or create your own web server for the project. To complete the page, we add a content div. In the content, we allow the user to choose the note type. The code is just pure HTML. We add two notes, meal and shopping. Then we insert an input box for the note text and an inline button that adds the notes to the list. Finally, we insert an empty list that will render the note data. Let's see how it looks in a browser. The page looks good, but interaction is not supported on it. We create an app.js file in the JS folder and link it to index.html. We know when the user clicks on the add button, it needs to add a note. We create an add note function to do so. We use the HTML5 local storage API to persist the data. When a note is added, we need to read the existing data from local storage and append the note to the existing data and save it back. Once we have something in local storage, we need to render it to the list item. In the render list function, we load notes from local storage first, and then loop through each item and append the item to the list element. Then we need to call the jQuery mobile method to refresh the list view and effect the changes. Then we add a clear list function to clear the list on the DOM. Next, we need to render the list and bind events to the add button once the document has been fully loaded. Once the add button is clicked, we grab the current note type and note text from the DOM elements and generate a note. Then we store the note using the add note function. After that, we clear the DOM list and re-render it. Let's see how it works on a browser. So far, we have successfully created a jQuery mobile application. Now we wrap it with PhoneGap so that it can be deployed to mobile devices. Create a PhoneGap project. Remove the demo app. Copy all assets from the project folder to the PhoneGap www folder. Then add iOS platform support and run the Cordova prepare command to stage the source code. Then add iOS platform support and run the Cordova prepare command to stage the source code. Open the generated Xcode project in Xcode. Here's what it looks like on an iPhone emulator. In this video, we have demonstrated how to develop jQuery mobile applications and deploy them to mobile devices. There are many good web application frameworks out there, like Backbone.js, Require.js, and Angular.js. The point of this video, however, is not to introduce all those frameworks in detail, rather how to wrap those web applications with PhoneGap so that you can deploy them to mobile devices. In the next video, we will talk about JavaScript object-oriented programming, modular, and testing. In the previous video, we developed a mini notebook, which is a jQuery mobile application. In this video, we will mainly focus on how to increase the quality of our project and demonstrate this with the mini notebook app. JavaScript is not like most object-oriented languages, which have explicit class definition. In JavaScript, a class is defined as a function, and its prototype is used for inheritance. Now we will refactor the mini notebook app to use OOP. The mini notebook can store the user's note text and render all the notes to a list. We have the class diagram, in which the persist class will persist and read the note text. The note class has two child classes which are responsible for the meal and shopping notes. Also, the DOM list class will render the DOM list with data from the persist class. Let's see the code. For the sake of convenience, we create a persist.js file for our persist class. We first create a persist function that will be used as a class. Then we define methods on its prototype. The first is the storeNote methods. We copy and paste the existing code from app.js. The second method is getNotes, which will return the note array. Again, we reuse the existing code. Now, when the script is loaded, we would like to initialize a persistence instance. Use the new keyword followed by our persist function. The persist object now has the storeNote and getNotes methods. In the same way, we create the DOM-list class. It needs a parameter in its constructor. We add the clearList and renderList methods. Finally, we create a note.js file. Create the note class and its addNote method, which simply passes a note text to the persist object. Then, the mealNote class inherits from the note class by initializing the note class and passing the instance to the mealNote class's prototype. This is how prototype inheritance works in JavaScript. Now, we end the class by overriding the methods. Do the same thing with the shopping note class. Go back to app.js. We still need some code here to use our classes. When the document is fully loaded, we initialize a new DOM-list instance and render it. Then, according to the input type that the user chooses, we initialize different note classes. Pass the user input to the note class and refresh the DOM list. Then add a reference of the JavaScript files to index.html. The app should now work the same as before. Modularizing is another way to organize your JavaScript code and increase your project quality. In JavaScript, we use closure to define a module. Here is an example. Assume we want to develop a map module for our app. It has two interfaces. One displays the user's current location on the map, while the other simply returns the reference of the map object that's encapsulated in the module. It requires an interface from another module to dispatch events. Since JavaScript is an event-driven language, we can provide an event interface, which is triggered when the user's location changes. Also, it requires an app-ready event. This will trigger the module initialization process when the app is ready. Let's see how it looks in JavaScript code. First, it uses a closure function to create the map module in our app. The map module could already exist, and it will extend and override the interfaces. The first two lines define the exported interfaces. To make the interfaces of the module prominent to other developers, we put them at the beginning of a module. The getMapObject function returns the reference of the private map object, which is not globally accessible. Events interfaces are defined next. Since there's no actual function to describe an event interface, we put some comments in to say that this module provides a location change event. Event subscribing is quite common. We have used it in the Hello World application tutorial to handle the device-ready events. Finally, it depends on an interface called dispatchEvent, which is provided by the events module. With PhoneGap mobile applications, we can use some testing frameworks like Mocha. For browser testing, Mocha provides a template that can be found on their websites. Let's see how to add tests to our mini notebook application with the help of frameworks and templates. Once we have the template ready, we create a test cases folder. We write a test for the persist class for this demo. The test case uses BDD syntax. It first generates a note text and stores it to persist. Then it loads back from persist and asserts if it contains the generated note. Once the test case is created, we need to add both the source module and the test case to our test.html file. Open the test.html file in a browser. Check if the test passes. In this video, we primarily introduced how to use PhoneGap along with some popular app frameworks and how to improve the quality of PhoneGap project. In the next video, we will learn how to use PhoneGap APIs.